Okay, so these next few are probably some of the more difficult ones. This is what's called a composite transformation. What it is in the composite transformation is you're actually doing two transformations at once, like you're going to rotate and reflect, or you're going to translate, etc., etc. So it's translate, then dilate. All of these that you see right here have the dilation element. And if you look at your formula chart, guys, the dilation is any time you have a factor in front of your coordinates and you're changing the coordinates by multiplying. So like if this said x, y went to 5x, 3y, you know, etc. So, or 5x, 5y. So what we're doing is we're looking at two separate transformations here. The first transformation that you're going to see is this -5 plus 6. That is the translation, okay? That is the translation. Then you see the dilation, okay? So what you're going to be doing is you're going to dilate this guy and you're going to translate it. What you're going to do is you're going to plug every coordinate. If you don't want to think about this as a composite, you're going to plug every coordinate into that formula. So let's do this the most compact way we can. J. Where is J located? J is at 1, 2, 3, 4, 5. -5 down 2. So my original J is at -5, -2. Okay? My original Z, JZ, right? Of course, that was definitely not intentional because we math teachers aren't that cool. So Z is located at 1, 2, 3, 4, -4. And then notice Z's on the x-axis. It's not up or down at all. So its y-coordinate is actually 0 because it's not raised or lowered. And then L is not left or right at all, so its coordinate is 0, and it's down 1, 2, 3. Okay, so what you're going to do is you're going to take each one of these coordinates and you're going to plug in each of these numbers into these particular formulas. So what does the first one say? We're going to take all of these x values and change them into the opposite of x minus 5. So basically, I'm going to take the opposite of x minus 5, and I'm going to plug in all three of these. Okay? So for example, the opposite of x. Well, what's x for the j coordinate? It's -5, right? So to show you this, I'm going to do negative x. Well, what's x? -5. So it's going to be -5. Do y'all see why? Because it's telling you negative or opposite of x. And then what am I going to do with that number? I'm going to subtract 5 from it. That's how I'm going to get my x coordinate. -5 is actually +5, and 5 minus 5 is actually 0. So that's your new x coordinate. Okay? For my new y coordinate, I'm going to plug all my y coordinates in to this one, -y plus 6. So I'm going to do opposite of y, and if you look at the picture, or here, my y is -2. It's opposite of -2 plus 6. Sorry, it's a little small there. What's -2? That's actually just +2, and then 2 plus 6 is 8. So that's my new J. All I did was I plugged each of these into there. That -5 got plugged into there, and that 2 got plugged into there. You can enter it in your calculator just like that, okay? So let's look at Z. If I look at Z, I'm going to do the same thing. I have negative of whatever that coordinate is, and for Z it's -4. Again, I'm plugging this into that. So it's negative, it's the opposite of -4 minus 5. See how we just did it just like up here? Negative negative 4 becomes just positive 4, and 4 minus 5 is negative 1. So that's your coordinate for z. Now let's do the y coordinate the same way, okay? The y coordinate, you're going to plug into that, okay? So I'm going to have negative, and in this particular instance, what is my y coordinate? 0, right? So negative 0, which is just going to be 0 plus 6. So, oh, I should have written this up here, sorry. So for z, you have negative 1, and then you have 0 plus 6, which is 6, so that's your new z coordinate. So that's how you do those particular examples. You're just going to plug in your numbers, your coordinates into those equations, okay? So if I look at 12b, let me adjust this. Okay, if I look at 12b, you're doing the same thing, except now what are you applying? All of the x coordinates get plugged into here, this negative x minus 2 thing, and all of the y coordinates get plugged into here, y plus 1. So basically, I'm going to multiply every x coordinate by a negative number, or I'm just going to flip the sign and then subtract 2 of all the x's I get here. And here I'm just going to add 1 to all the y's. And that's how you do the composites. Okay? So these are a little more difficult. They're a little more difficult. I'll give you a couple of examples for this one, and then I'm going to move on to the symmetries. So, for example, f is over here at 1, 2, 3, 4, 5. F is at negative 5, comma, 1, 2, 3, 4, 4. Y is at negative 5, comma, 1. And G is at 1, 2, 3, 4, negative 4, comma, 2. Can you get him some PJs? So, sorry, my little one needs PJs. So, to get to the new one, we're going to take all of these x coordinates and we're going to plug them into this negative x minus 2 thing, right? And then we're going to take, to get to the new y value, we're going to take all of these y values and plug them into this y plus 1. Let's do the y's first. The y's are easiest because all we're doing right now with the y's is y plus 1. So let's do the y plus 1. I'm gonna actually just do this so that we can actually see the calculations. So 4 is your y coordinate. What's 4 plus 1? 5. This is 1 for this one. What's 1 plus 1? 2. This is 2. What's 2 plus 1? 3. Okay? So that is your y value. Your x value, we're going to plug into negative x minus 2. So I'm going to do opposite of x. If you look at this, opposite of x and then subtract 2. What's the opposite of x? 5. And what's 5 minus 2? It's 3. What's the opposite of x? 5. And what's 5 minus 2? 3 again. What's the opposite of 4? Negative 4. 4. And what's 4 minus 2? 2. And that's where your new figure is going to be. And that's how you do the composite transformations. 13a is another one. On 13a, you're doing the same thing. You're just going to plug into 2x plus 4 and 2y plus 7. So you'll get your points and plug them into that one. The last one that you have is reflection and rotation symmetry. 15a. Okay. Figures can have two types of symmetries. There's two types. And actually, I'll do this on a different video.